Configuring backup specifications. As you see from my right brace over here, the centerpiece of this nugget is Oracle Recovery Manager, which we affectionately call RMAN. The exam objectives we're covering here are configuring backup settings. Basically, this deals with setting global defaults that are used within RMAN when we run the application. And then we'll look at channels, which forms the server processes or the data streams between RMAN and the data that you're backing up or restoring. And finally, we'll look at a toggle feature, either it's on or off, called backup optimization. There's really not a lot to that, and in my opinion, it's one of those options that, as a no-brainer, ought to be turned on. I'll tell you why when we get there. Let's get to work. First, let's take a look at some background. Exactly what Oracle assets are we protecting with RMAN? I've broken it down again along physical and logical boundaries. Our physical assets that we're protecting with Oracle RMAN are, of course, our data files where the main corpus of our business data exists, our control files, which are small binary files. Again, we don't need to define it. We just know that the instance and the database are going nowhere unless we have at least one valid control file. And we're also protecting our archived redo log files. We now know, if you've been following these nuggets in sequence, what redo log files are, why they're crucial, and why you should be running your Oracle database in archive log mode. If we want to do PIT, or point-in-time recovery, it's essential that we not only take regular backups of our data files and control files, but that we also archive or bring back our archived redo log files to roll forward transactions. Now, again, global term here, basically some background information. Oracle defines two types of backup strategy in Oracle. There's the RMAN-based backup and the user-managed backup. And in Oracle nomenclature, and if you see references to this on the exam, we're leaning very heavily in the direction of RMAN backups. With RMAN backups, we're using the RMAN tool through the use of server sessions or channels to back up files, to do backup sets, to copy files, to restore files, and recover those files. Remember the difference between restoration and recovery. Restoration deals with placing an asset, a physical asset, back into its proper location. Recovery means synchronizing the data and making sure that only committed transactions are re-recorded onto your restored files. Now, user-managed backups in Oracle nomenclature means that we are issuing essentially operating system commands, something from the Unix, Linux, Mac OS X, or Windows command line, xcopy, copy, cp, and so forth, to back up files. You also can use third-party applications, again, to back up physical files that exist in the Oracle home directory on your servers. Now, this is obviously a weaker solution for many reasons. RMAN has complete knowledge, if we want to call it that, of the instance and of the database, whereas your operating system commands and your third-party applications do not have that kind of insight. There's also the issue of cold versus hot backups. If we have service level agreements, for instance, that require that our database be online 24 hours a day, then that's going to necessitate hot backups, which is going to necessitate the use of a tool that can do hot backups, namely RMAN. Come down to the logical side. When we deal with logical elements, we're talking about things like schema objects, your tables, your indexes, stuff that doesn't exist as such in the file system. And ironically enough, or interestingly enough, we're not concerned with this backup and recovery method, that is, the import and export of schema objects. We actually covered that in the DBA 1 course. So if you need information on getting table data out of Oracle, maybe you're doing an ETL or an extract transform load where you need to take data from one database and pop it into another, that second database might be a completely different platform like Microsoft SQL Server. Oracle has a tool called the data pump, and like I said, we do cover that fully in the CBT Nuggets DBA 1 training course, but that's what we've got going on. RMAN is not used to back up logical elements. We use a separate tool for that. I actually want to make a couple more points of differentiation between the RMAN or Recovery Manager backup method and the user-managed method where we use operating system commands. One big differentiator is the API or Application Programming Interface of RMAN. A little bit later in this nugget we're going to talk in more detail about that, but basically Oracle publishes the programmatic rules or hooks that enable developers to plug their own backup and recovery tools into RMAN. Think of an enterprise backup solution like Tivoli, for instance. Your organization may be using Tivoli to back up the rest of your infrastructure. Fortunately, there are features of Tivoli that enable you to tap in and understand RMAN and basically remote control RMAN and take advantage of all of the intimate knowledge of your database that RMAN has. Of course, we don't have any of that API stuff in a user-managed scenario. Computing checksums and error checking is another benefit of the RMAN backup approach that user-managed cannot claim. And finally, we have the notion of incremental backups. Being able to save disk space as you back up night after night after night. You're just backing up changed blocks with an incremental backup. Can't do that with just a user-managed file copy. You're going to have redundant copies of those files, or the entire file that inside that file contains your delta or your changed blocks. But that's going to involve a much higher and larger disk footprint. Again, by way of background information, there's the question, well, where are the files? Of course, you should be familiar with tools for gathering metadata in Oracle database. We have our data dictionary views that provide the locations of your control files, of your data files, etc. You'll remember also from our DBA1 training or your prior experience with Oracle that the standard data dictionary views are prefixed user all or DBA. The user underscore views allow you to see objects that are owned by that particular user. If you are a regular user, for instance. So in other words, if Joe user were to log into Oracle database using, let's say, SQL Plus and run queries against user underscore views, user underscore tables, let's say, that user would see only the tables that he or she owns. All underscore views, by contrast, will give a user a view of metadata on not only objects that they own, but any objects to which they've been granted privileges. So it's a wider scope of metadata. We as database administrators are going to query the DBA underscore views, which allow you to see absolutely everything, especially if you're logged in with sysdba privilege. You have insight across the entire database with no restriction. The second type of view is called the dynamic performance view. These views are prefixed with $, thus these views are often called colloquially $V views. And the dynamic performance means that we're able to see live dynamic data. Stuff by stuff, that's my technical term of the day. I'm referring to quantitative information that tends to change in some cases from second to second, like memory allocation, disk space allocation, stuff like that. And you're able to snapshot that information by running queries against $. Now that we've done our necessary due diligence and review, let's get into the meat and potatoes of this nugget. Now, what the heck is RMAN? We're formally introducing the tool in this utility, and you must, I do stress you must, be very proficient with RMAN before you sit for your DBA2 certification exam. You'll remember that before you took your Oracle SQL Fundamentals test, you knew that it would be pointless to do so unless you were very proficient with structured query language. Same thing applies for our DBA2. Our centerpiece application here is Recovery Manager. And as we probably know by now, RMAN is the built-in, that is to say free, backup and recovery tool in Oracle 11g. Now, it's been in Oracle for many, many versions. It's not new by any means. That is to say, if you have prior experience with Oracle, you probably are somewhat or very familiar with the tool anyway. Now, RMAN has two versions. Now, versions is a little bit tricky. Basically, there are two entry points to RMAN. You can either interact with the executable directly in a command line interface, or you want to use a graphical user interface, we can use Oracle Enterprise Manager. And that makes it a lot more, let's say, user-friendly to run RMAN by using the GUI. I'm going to show you both in this demo and in upcoming demos throughout the training. Essentially, what you need to know is that OEM is a web application. When you're going through those graphical wizards to set up backup backup jobs, what's happening in the background is OEM is issuing RMAN executable commands. Basically, OEM is simply abstracting your having to know the command line commands. Well, that's all well and good for your convenience, but you absolutely need to know the basic RMAN syntax in order to pass your DBA2 test. So I can't stress that enough. So besides using RMAN to actually perform our backups and our recoveries, our restorations, we also can use RMAN as a query tool. RMAN is a self-contained environment. It does have its own set of internal commands, just like SQL Plus has its own internal commands for dealing with databases there. Here in RMAN, we're dealing with our database from a disaster recovery point of view. So we have rich metadata storage and reporting. As we're going to learn as we proceed, you can store your RMAN information in one or two places. The control file is the default location for RMAN metadata. In other words, what's being backed up, when it's being backed up, how long it's taking, what the file size footprints are. All of that data about data is actually stored in the control file. Now, another option is to use a separate database called the recovery catalog to store metadata. And recovery catalog, as we'll learn elsewhere in this training, is great for two reasons. One reason is that you can store far more information in the recovery catalog than you can in the control file. The control file eventually is going to circle back upon itself. The second thing that's cool about recovery catalog is that it's a shared database. That is, you can use multiple database instances and pipe them all into the recovery catalog, so you can have an enterprise level metadata collection for your RMAN disaster recovery. That's very useful. And actually, I just now thought of a third cool thing about the recovery catalog. You can store RMAN script files in that database and have them be shared among several other registered database instances. Isn't that awesome? Anyway, we'll talk more about recovery catalog in great detail elsewhere. The RMAN executable supports features like compression and encryption. Those are pretty standard. Any backup utility needs to support those, especially nowadays with governmental regulations and industry regulations that require data protection. And compression, even though disk space has never been less expensive than it is now in the 21st century, why waste disk space when we don't have to? Now, I mentioned in the previous whiteboard that the RMAN application programming interface is available to third-party developers, but you don't have to be a third-party developer to make use of RMAN from an automation standpoint. We have eminent scriptability with RMAN. In fact, let's dive into that to a little greater degree. How do we actually use the RMAN tool? Well, there's two ways to go about it. One is to fire up the RMAN executable. The other is to compose what's called a run block. And a run block is very simply the word run. It's run in the RMAN command language. So you already have to have RMAN loaded into memory to execute a run block. And then in curly braces, I know those are horrendous curly braces, but I hope you get the idea, you have your various RMAN commands to configure the environment, to perform a backup, to perform a metadata query, to perform a restore, whatever the case might be. First, let's look at interacting with the RMAN executable directly. One way that's very common is to actually start RMAN from a command prompt and run commands interactively in the RMAN shell. That's what we're going to begin with in our upcoming demo here. You can do that all day long. There's some rudimentary online help, some syntax helps, and you can just work, like I said, interactively ad hoc to your heart's content. Another way to interact with the RMAN executable is through an operating system shell script. This could be a .cmd or bat file in Windows, or a .sh script in Unix, Linux, or Mac OS X. And basically, as you know, with a shell script, we're simply echoing operating system commands, such that we can echo a login to RMAN target / for instance, and then put in maybe a run block or just straight ahead RMAN commands, configure commands, backup commands, etc. And the idea, of course, is that we can, with a double click or a cron job or a task scheduler job, run that OS shell script and have those RMAN commands happen automatically. Many Oracle administrators will run backups using operating system shell scripts. It happens all the time. Third, again, we have the notion of the RMAN-aware application. Your company and your IT department may have already invested in an enterprise disaster recovery application, and you may have a business requirement to back up an Oracle database or more than one Oracle database using that tool. Most enterprise tools nowadays, and I say most because of course there's vendor infighting and capitalism that prevents this from happening in some cases, but most of your enterprise disaster recovery tools have taken advantage of the RMAN API and can transparently plug into RMAN to take care of Oracle-specific hot backups and recoveries. Alrighty, now the run block, as I said, is a command set that's a very specific format, and you can run blocks within RMAN in an interactive session. That is, you log into RMAN and then create your run block and go from there. Now, that's cool, but not particularly useful, because once the run block exits and you close RMAN and come back into it, that run block is not persistent. It's gone. If you want the run block to be persistent, you'll want to put it in a script. And as I said in the previous whiteboard, you can store scripts either in the file system and store them as separate files. Typically, we give RMAN scripts an extension of .rman to make it easy for us to know. They're just plain text files after all. Or actually, a benefit of the recovery catalog is that we can store our RMAN scripts in that database for transparent execution from any registered database. So I hope this gives you some nice theory on the primary ways in which we use RMAN. Finally, just for completion, I will repeat that we can log into the Oracle Enterprise Manager web application and access backup and recovery tools there in a graphical environment, and we don't necessarily have to know that behind the scenes RMAN is being configured and run. Configuring channels. And while we're on the subject, we'll talk about configuring RMAN, or configuring the RMAN environment to be more specific. You should know that RMAN operates with a series of settings, a series of default settings that you as an Oracle administrator have full privilege to change. I mentioned that RMAN is its own self-contained environment, as you'll see in the upcoming demo, and in RMAN we use the configure command to override defaults. Now, one of the things that's important to specify, if you want to be granular about it, is the concept of the channel. Now, a channel is required in Oracle RMAN because the channel is the data stream, or the connection to a database server session that RMAN uses to perform backup and restore operations. Let's take a look at the Oracle documentation for a minute and see what they have to say. They say basically what I just told you, that an RMAN channel represents a single data stream to a device type. That's an important bit of knowledge. The default device type used in Oracle RMAN is disk. So we're assuming that we're backing up our database or database assets to the file system. And that could be the flash recovery area, or it could be a designated different area that's up to you as an administrator. Now, Oracle also supports writing to tape, which in Oracle RMAN nomenclature is referenced as SBT, as we'll see. This is an important picture, I think, because it shows the interrelationship between RMAN, the target database, and then ultimately where your backups are going, or your restorations and recoveries are coming from, disk or tape. But specifically, I want you to see right off the bat that you're not at all limited to a single channel. Although RMAN in Oracle 11 GR2 gives you one default channel that's configured for the disk type, you can, as an administrator, specify as a default multiple channels, and you can also jog another option called Parallelism to write and read multiple data streams. Okay? Now, as far as the channels are concerned, you can use allocate or configure depending upon whether you're just doing an ad hoc or one-time manual run of an RMAN block, or as I said, you want to change or override a default. So configure channel results in a persistent change to how RMAN operates out of the box with regard to channel data streams. In an RMAN drop, in an RMAN block, you can use allocate channel to open up one-time or manual use channels. We don't want to overthink this because there's really no need to. Configuring channels doesn't have to be that difficult. Before we jump into the demo, one final subject, and that is the exam objective called backup optimization. As I mentioned in the introductory slide of this nugget, backup optimization is essentially a toggle switch. You use the RMAN configure to turn backup optimization either on or off. Why I think this is a no-brainer option for most administrators is that it's going to save disk space with no effort on your part. Basically, when you enable backup optimization in RMAN, RMAN will automatically skip or not back up physical assets, data files, archived log backups, or entire backup sets that have already been backed up. So RMAN, as you know, has intimate knowledge or stored metadata of your backups and the individual, as they're called, pieces or atomic elements of your backup sets. Therefore, as you run your backups each night, Oracle with backup optimization can see whether a particular element has changed in between the previous backup and this one. And if there's no change, we're not going to redundantly back up that asset. In a sense, backup optimization is somewhat akin to incremental backups, but it works at a more granular level. Welcome to our demo on configuring backup specifications in Oracle Database 11G R2. We're going to begin this demo by reviewing where the files are. That is to say, where are our data files? Where is our Oracle installation housed? Where are our backups stored? All of this can be found in a variety of different ways. One way, of course, is just to simply check the file system on your Oracle server. The specific means that you use for this are going to depend a little bit upon whether you're in a graphical or windowing operating system and the specific platform, namely Windows, Linux, or Mac OS X. Now on this particular box, my C drive is my system drive on which I have Windows Server 2008 R2 installed. On drive D, I did a fresh installation of Oracle Database 11G R2, and I used the default Oracle naming conventions here, such that I have my Oracle base under D app account owner, and I have the Oracle home stored under further product 11.2.0 db home _1, and eventually we get down to our binary files and our support files for the database itself. Now if I come back to DApp Administrator or a data, I'll find a subfolder that defines our default location for our root files, our data log files, our online redo log files, and our control files. We can customize the location of all of these things either through SQL Plus or through Oracle Enterprise Manager. It doesn't matter. Let's start by quickly logging into SQL Plus as the operating system user and as sysdba. I'm going to select name from the $$ control file system view, and that will give us a quick run of the location of our multiplexed control file. And again, this is factory default after having run a fresh installation and accepting the base defaults in the database configuration wizard. Now if we want to change that, this is again a little bit of review from the DBA1 skill set. We can just first of all look at the specific values, show parameter if I can speak, if I can type that is, control_files, and that tells us the name, and we can do an alter system set if we need to change the location of our control files, but I think we're fine. As far as the online redo log files, we can do a select member from $$ log file, and that will echo back the location of those files, 3 by default, and we can do a select name from $$ data file to get a quick echo of our current database's data files. Now all that stuff, as I just mentioned, is also available to us through the graphical interface in Oracle Enterprise Manager. I'll quickly log in now, and if we navigate to the server page under storage, we can look at each one of these elements specifically. I'll just go to data files here for grins, and we can get very detailed information in this view on all of the data files for the currently active database, the table space in which each data file lives, its status, its size, etc., etc., etc. Enough review. Now let's get into the new stuff, specifically configuring the RMAN environment. Now I'm going to exit out of SQL Plus, we'll clear the screen, and we'll fire up RMAN. Now with RMAN, we're going to learn as we go along. The most common way to get in is setting a target. Now if we don't specify a database name as the target, then whatever is the current value value for Oracle SID is going to be the database target that's used by RMAN. And we can use export in Linux, Unix, or the set command in Windows to change that Oracle SID environment variable if you do happen to need a connection to a different database. Otherwise, as I said, we can start RMAN simply with RMAN target to go to the current Oracle SID, and moreover, we can authenticate using our current operating system account with the /. That'll take us into the Recovery Manager executable, and if we want to show all of our persistent settings, we can run show all to get a list. And these come back in uppercase. It's kind of difficult for me to read, and any that are set to factory defaults will show up with #default to let us know that information very quickly and easily. So you notice that the retention policy here is set to just one copy. That's the default. Backup optimization is turned off. We're going to turn that on shortly. The default backup device type is disk. Control file auto backups are turned off. We're going to turn that on in just a second. You can customize the location and name of your control file in the auto backup with this control file auto backup format for device type disk statement. Boy, say that 5 times quickly. We can set disk parallelism, the default backup type, which you'll notice that parallelism is 1 by default and backup sets are used as opposed to image copies by default. The number of backup copies is set to 1, so we're not doing a multi-copy backup out of the box. Archive log, same thing, just 1 copy. The maximum backup set size is not capped by default. Encryption is turned off by default. Archive log deletion policy is not configured by default, and the snapshot control file name is given as this as the default path. So those are the configure settings. We can override any or all of them in a run block in an RMAN script file. By contrast, if there are settings that you want to persist on every RMAN session, we can use the configure statement to set those defaults. The first one we're going to turn on actually is the control file auto backup. So I'll just simply type configure control file auto backup on. Make sure to throw that statement terminator, that semicolon in there, and now it tells us that that parameter is successfully stored. We can now say show control file auto backup, and that will give us the current show status of that parameter, and it tells us what we already know, namely that from now on when we run backups from RMAN, unless we explicitly turn this off in our run block, then our control file will be backed up, which is a good thing. It really is. Now you can also, if you're in an SQL Plus environment, run a quick manual backup of the control file. You'll remember the alter database backup control file to trace statement, and we can even specify a path like so. Of course, this statement is not going to work in RMAN, but I just wanted to let you know it's very easy to take a quick snapshot backup of your control file from SQL Plus if you want to. Now, as we talked about in the theory portion of this nugget, by default, we're going to be using the flash recovery area for our backup destination, and you already know how to configure the FRA both through SQL Plus as well as through Oracle Enterprise Manager. Let's mosey on over to the availability page, come down to recovery settings to see what we have set on this particular server. And we see that flash recovery area is set for DApp administrator flash recovery area. Well, in this case, I'm going to switch that out. I'm going to actually go to another disk that I have here, my E drive, and I'm going to create a folder called FRA to denote our flash recovery area. I'm going to specify that right here just by typing the path directly, E:\FRA, and I'm also going to boost the size of the FRA to 6 gigs. Now you notice here before we click apply that if we just want to change this parameter in the current SP file, and in other words, don't mess with the running config of the system, we would tick this box. By default, the parameter change is going to go into effect live in the running instance, and also the next time we restart the database, that change will be persistent there as well. So let's click apply. We're asked for operating system credentials here, so these are going to be your Windows, Linux, or Mac OS X administrator credentials. I'm going to save those as preferred credentials, and it tells us the changes have been been successfully applied. Let's come down and we can see that EFRA is going to be our default save location. Now let's test this out in RMAN by running a quick backup. We can do that very quickly with the RMAN statement backup database. Very easy. Not specifying any formatting options, not specifying anything special with channels. We'll talk about channels in just a moment. Now, you'll notice that this process bombed out or it errored out. I want you to become really familiar with the feedback syntax you get from RMAN. It's actually really useful, and I find in my professional experience that RMAN does a great job of documenting line by line what's going on. For instance, you'll notice here that we have an RMAN 03009 error and an ORA 19602 error. So we have an Oracle error and an RMAN error. Take note of those numbers, because in the real world, when you're troubleshooting issues in Oracle and with RMAN, it's going to be really useful for you to have those ID numbers right there handy, you see. Now, each line here has an associated ID. Don't worry about 571, 569, and 571. Those are statically assigned, and those just generate the graphic here, the error message stack follows. What we're concerned with is that our backup command failed, and the error is we cannot back up or copy an active file in no archive log mode. Well, it looks like I haven't enabled archive log mode in this database. Well, that's not cool. Well, I'm going to just come back to Oracle Enterprise Manager. Instead of doing this through SQL+, which you know, of course, we can, I'm going to specify archive log mode. I'm going to use the DB recovery file dest initialization parameter as the location for our archived redo logs, and I'm going to leave the default file name format using the SR and T substitution variables. Now you remember, if you've been following these nuggets sequentially, that this change, moving a database into archive log mode, is going to require bouncing the database. So we receive a confirmation here that asks us, are you sure you want to do that? Which I do. And even still, we have to provide not only OS or host credentials, but also our sys credentials here. So I'm going to supply my username and password here for sys, make sure that I'm connecting with sys DBA privilege. I'm going to save that as a preferred credential and click OK. This lets us know what we're going to do to our SP file, and we're going to click yes to bounce the database. When we see our home page appear, we can rest assured that the database is back up. We're going to need to exit out of RMAN and log back in to reestablish our connection. So let's clear the screen and do another RMAN target / to get back into RMAN. And now let's try it one more time with feeling. Backup database. Now we could include the archive log if we want to by just specifying plus archive log. I'm not going to in this first example. I'm just going to do a backup database. Now this looks like this is going through just fine. Again, I want to take a look line by line what's going on here. Tells us that it's starting the backup on March 16th, 2012 using the target database control file settings instead of the recovery catalog. We'll be working with the recovery catalog in the next nugget. Now note that it said allocated channel. The neat thing about channels in Oracle is that you really don't have to know about them. That is, you don't have to use channels or parallelism unless you actually want to. If you specify parallelism in your configure settings, then Oracle will automatically spawn channels that map to each of those parallel data streams. By contrast, and you'll see this in the next example, if you decide to allocate channels, you don't need to specify parallelism because Oracle will spawn the parallel processes to match those channels. While we're waiting for this database to go through, I want to share that documentation with you. There's some really cool Oracle blogs out there. You always want to be careful, of course, when you're turning to a non-Oracle source for information, because as you know, just about anybody with low to intermediate tech skills can bring up a blog and say anything they want to. That having been said, this person's blog, this is a Turk named Amre Baransel. I hope I'm pronouncing his name correctly. This particular post of his is cool because he synthesizes a lot of complicated concepts from the Oracle documentation and puts them in pretty easy to follow terms. In particular, I want to show you this section here, the relationship between configuring channels using configure channel and configuring parallelism using the parallelism clause in RMAN. The documentation says that RMAN always allocates the number of channels specified in parallelism. So if we set configure parallelism to 3 and run a backup, we can rest assured that Oracle will automatically spawn that number of channels for for us. Now, that auto allocation will not happen if we've specifically configured channels. If we configure specific channels with a number higher than the parallelism setting, then the setting prevents RMAN from using them. Thus, if we have parallelism set to 3 and we use allocate channel 4 times, then that fourth channel is not going to be used because we've effectively capped the parallelism using the configure statement. Alright, back to our regularly scheduled programming. We see here after our statement on the recovery catalog what's going on, our default device type, and we're starting a particular backup, whether this is incremental, differential, image copy, tells us that we're doing a full data file backup set. Not compressed, because as we saw earlier when we ran show all, that's not the default setting. Next, we're going to list out all of the data files that are part of my ORCL database. Boom, 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 boom. We saw these in Enterprise Manager a few minutes ago. And then we see one channel being spawned. We didn't allocate this manually. This is automatic channel creation by Oracle itself, and it's creating a single backup set using a single backup set piece. I also want us to pay attention to this line here where it talks about piece handle. Note where it's writing the file. EFRA, ORCL, backup set, date, etc. You see? So this proves that we're going to be writing our backups to the flash recovery area by default as long as we do in fact have an FRA configured. Now we can always use the format command to specify a different location, either permanently in the configure statement, or as you'll see in the next example, we can just use the format clause in the allocate channel statement and do it on a channel by channel basis. Now we haven't seen any errors. It tells us that the backup set completed, and then because we have control file auto backup set up, it's going to back up the control file, and this is interesting, your server parameter file gets part of that backup as well, and that gets thrown into the flash recovery area as well. Now let's just jump over to our E drive to dip in and take a look. So under EFRA, name of the database, we have two subfolders created for us by Oracle, one for the actual backup set and the other for our control file and SP file auto backup. Let's go in there first. We're going to see that we have a date stamped folder 3/16/2012, and then we have the SP file and the control file bundled in this single BKP package that uses Oracle managed file syntax. It's a very convoluted name, but the biggest thing really is that it be a unique name so you don't run across a collision with those names. Back to EFRA or ORCL, let's go into our backup set folder, and we have the backup set in its own date stamped subfolder, and then finally we come to the backup file itself, again using Oracle managed files. Now we can see those files also in Enterprise Manager very easily. On the availability page in Manage, we have Manage Current Backups, and this is going to allow us to see very quickly and easily what is going on with our RMAN backups. So it shows us here both of those operations. First, the data file backup, and next, the control file auto backup. And if we click the link for that particular item, we can see again all the appropriate metadata, the specific files that were backed up, and then down below the output file. In other words, the contents of that backup set and its availability. That's something we'll look at in a separate nugget later on reporting in RMAN, where you can mark and check out obsolete, expired, incomplete, unavailable versus available items. You can also filter that view here and cut down on what you're seeing. I mean, over time, depending upon how large your infrastructure is, you could have a lot going on in this box, and it's helpful that Oracle allows us to filter the view to see only what we need. Note also that we have a distinction between backup sets and plain old user-managed image copies. We'll talk about imaged copies again a little bit later in the training. Now, the next thing we're going to do is create a just ad hoc run block. We open up a run block with the statement run and open curly brace, and I'm going to allocate a couple channels here. I'm going to call my first channel C1, and I'm going to specify device type disk. The other option is system backup tape or SBT, and we're going to throw in format here to override the flash recovery area. Now, before I type a path, it would probably be helpful for me to create a path here, so let me come back to E, and I'm going to create two folders here, one called backup 1, that's going to serve as our first backup destination, and I'll create a second folder called backup 2 that'll serve, you guessed guessed it, as our second backup destination. So now I can throw as a string a specific file path here where I can say E backup 1 and then give the file a name. Now I can give it a hard name, but that's not all that useful when you want to automate this stuff. So I'm going to use a substitution parameter, a substitution variable I should say, of %u. This is going to guarantee a unique file name. That's what the uppercase U means. And of course this is case sensitive. Hit enter to go to line 3 in my interactive environment. I'll allocate another channel. The names here are completely arbitrary. Device type disk, format E backup 2. Again, I'll use %u to generate a unique name. Now the actual backup operation, I will say backup database. And I'm not going to throw in the archive log here, although remember, plus archive log is all we would need to do that. Throw in a semicolon. Remember, each of these statements is like any other SQL statement that needs a statement terminator. To close it out, we'll use the closing curly brace, and a newcomer mistake is to add a final semicolon. You don't need to do that. Please understand that. Okay, so we see here that the run block is being parsed and processed immediately by Oracle, and it's allocating each channel, device type disk, SID32, SID34, and now it's starting the backup. Now, the middle part here, what I want you to see is that it looks like channel 1 is grabbing these first two files, file number 1 and file number 4, and channel 2 is specifying file number 2, 5, and 3. So you'll note that a particular data file is not, unless you're doing a multi-section backup, going to be spread across multiple channels. A channel is going to grab up a certain number of files, and Oracle is going to try to be as fair as possible, if that's the correct word. We have a 2 to 3 split here. If we had 6 data files in our database to back up, then in all likelihood our channel C1 would have 3 and channel C2 would have 3 as well. Now I want you to see what's going on down below here a little bit further. A single backup piece is created and a backup set is being created again for each channel, even though it all corresponds to the same backup job. And I want you to see that channel 1 is writing its piece to E backup 1, and then there's that great big unique name. Channel 2, its backup piece is writing to E backup 2 with a great big long unique name. By the way, we're going to learn about tagging in a future nugget. Tag is a way for administrators to optionally give a human readable name to a backup piece or a backup job. Oracle will create a unique tag just to absolutely be double Dutch sure that your files are unique from each other, but it's definitely an Oracle power user secret to create your own tags when you're writing your backup jobs, just so it's very clear from an intuitive standpoint of what a particular backup means. We do our control file and SP file auto backup. That's going to our flash recovery area because we haven't specified a target for it in our run block explicitly. And then you'll note that the final things that happen is that Oracle releases channel 1 and channel 2. So we could, if we wanted to be really strict, put in a clear statement or a release channel operation in our run block, but you'll note that Oracle is intelligent enough to do that release on its own. Now let's come back to Windows Explorer and dip into backups 1 and 2 and see what's going on. Again, those unique names are pretty bizarre looking. That one's about 600 megs. Backup 2 is surprisingly, even though it was more files, is a little bit smaller. You can understand exactly what's going on in each of these backups by making use of reporting commands. And the common quick one in RMAN anyway is list. So we can run list backup. Now the output is pretty crazy. There are so many columns, and unless you're using the format column command, it's not going to be all that readable. A much better approach is, as I showed you earlier, to fire up Oracle Enterprise Manager and manage your current backups to take a look at a job by job basis, backup set by backup set basis, or you could also do a backup reports operation here and see exactly what's up. I mean, this is reporting that initial failure that we had earlier. It's nice that it gives you the size too, because disk footprint is certainly something that we need to be paying attention to as administrators. So if we look at a backup report for a specific job, we can get everything we wanted to know and more about data objects, backup, logical objects within those physical files, for instance, table spaces contained within particular data files. And if we go down below, we get, again, a lot of information on what's happening here. Let's complete this demonstration by setting a couple persistent options in RMAN. I'm going to exit out of RMAN temporarily. We're not actually exiting out of it. If we issue host with a semicolon, we can just duck out into our operating system shell briefly. I'll issue CLS. Of course, in Mac or Linux, you'll issue clear. And then when you type exit again, it takes you out of the OS shell and back into RMAN. I just wanted to do that to clear the screen for us. Now, as far as some of those persistent settings, remember show all to see them all, we can turn on backup optimization very easy. Configure backup optimization on. Boom, it's on. That's all there is to it. If we want to change the backup type to instead just of straight backup set, compressed data backup set, we can do a configure device type disk, backup type to compressed data, compressed backup set. Very easy. You see what I mean? What I'm hoping you're seeing as a general trend is that RMAN has a remarkably and comfortably human syntax. It really does. So once you understand what each one of these options actually means, just getting past the geek factor, and just spend some time practicing turning the options on, running backups, turning the options off, etc. It'll become much easier, I think, for you to leverage RMAN to your best professional benefit. These configure commands always allow clearing too. Let's do a show all just to verify that our compressed backup set is still there, and we could have changed parallelism too if we want to. To revert any of your RMAN settings back to default, it's just a question of using configure with the option name, at least enough of it so Oracle knows what you're talking about, and then issue clear. So it might take some playing around before you get it just right. If we want to set the default disk type back to its default, we could say configure device type disk clear, and it tells us that we were successfully able to reset that to default value. So now we can say show device type disk. And again, sometimes there's some playing around. It's expecting a particular syntax. I'll just do a show all. And we can see that our backup type for our disk backups is set to uncompressed backup set, and that is in fact the factory default value. So there you have it. Configuring backup specifications review. In this nugget, we got a thorough grounding in the basic operation of RMAN. We understand how it's positioned in the Oracle database application. We understand the major ways with which we interact with RMAN as administrators. And now, most importantly, for our exam success purposes, we know how to configure the RMAN environment, setting up default backup settings. We know what data channels are, how to configure persistent channels, how to use ad hoc channels using the allocate command. And then we also understand the backup optimization toggle and why that's generally speaking a good idea to enable within RMAN. I hope that this has been informative for you, and I'd like to thank you for viewing.